Let's get started.
Yeah, I love notes.
Woo. Focus. Focus. Hey, you. Focus. All right, so let's talk. We're going to start talking about scatter plots. Today we're going to be talking about residuals, which I kind of introduced to you guys already. We're going to also talk about correlation and causation today. And then Friday we're going to start writing equations for the line of best fit. And we're going to continue that next Tuesday because you guys have a 3-day weekend over this weekend. So you finally get a break. So that's where we're going. Don't forget about your clever assignments. Put your phones away, not on your desk. If I see it, I'm just going to ask you to give it to me for the period, and you can take it at lunch and give it back to me after lunch if you need to. All right. So scatter plots, graph used to determine whether there is a relationship between paired data. So a scatter plot is any data that has like just points, like randomly around. And with scatter plots, you can draw a line through it. Today's the 25th, sorry. And it is known as the line of best fit. Oh my goodness. So anyways, so the line of best fit is the line that goes through the center of the data. It doesn't have to connect the most amount of points. It needs to make sure that those points are as close to the line as possible so that those residuals are minimized, meaning we want the smallest residuals possible. All right? A correlation is a mutual relationship or connection between two things. So there are two types of correlation. There is positive correlation and negative correlation. There's also no correlation as well. So positive correlation is as the x increases in value, the y values also increase. A perfect positive correlation has a residual of 1. So this is a residual. Not a residual. That's not what that is. Sorry. That's a correlation coefficient.
What?
We'll talk about that in a second. I don't know why they used R. So the correlation coefficients can be anywhere between 1 and -1, and we'll talk about that in a second. But positive correlations will always have a positive correlation coefficient. The closer it is to 1, the stronger the correlation.
Wait, I have a question.
Yeah.
So, when it's like the closer it is to 1, is that like the y-axis if it's closer to 1?
No, we'll look at them. Don't worry. Just 1 second here. So a negative correlation is as the x increases, the y value decreases. So a perfect negative correlation has an R of -1, meaning those correlation coefficient, that residuals are as close to the line as possible, and it will be negative. Those correlation coefficient is always going to be between 1 and -1, or -1 and 1. And the biggest thing here, guys, you'll notice that it's always as x increases. Y will either increase or decrease. X will never decrease. So it will always be as x increases. Y will increase if it is positive. It will decrease if it is negative. So you're always going to start out as whatever the x-axis is increases. We'll talk about what the y-axis is doing. So what is a correlation? It is described as strong if the R is greater than 0.1. Or, so we know, let's talk about this first. It's between -1 and 1, right? Okay?
Are we going to have to memorize these decimals and stuff?
Not really. It's more like knowing, like by looking at it, if it's strong or weak too. So -1 to 1 here, because we're not teaching you guys actually how to just calculate correlation coefficients because that's a lot of work. We're just teaching you guys how to look at them right now. So if it's greater than 0.1 or if R is less than -0.7, meaning but it's never more than 1. So meaning that it's either strong correlation positively or strong correlation negatively. If it's positive, it'll be a positive. If it's negative, it'll be a negative. A correlation is described as moderate if it's between 0.3 and 0.7 or between negative 0.3 and negative 0.7. And a correlation is described as weak if R is less than negative 0.3. So, because you're talking about going towards 0. 0, if R equals 0, there is no correlation. Right, so that's a lot of stuff there. So when you're ready, go ahead and flip to the next page so we can kind of look at the degrees of correlation there. It's not on there. I'll put it on there for you. Didn't Justin literally just ask that question? Did you not hear that? I sometimes wonder about you guys. All right.
I ate 6 apples.
So, degrees of correlation. If you were to draw a line through this, the points are relatively close to all of them, right? Do you guys see how tight those points are to the lines?
Oh, yeah.
That's what makes it a strong positive or a strong negative correlation. So strong means, so uphill is strong positive, first of all. Downhill is strong negative. So if you look at the graph left to right, do you see how it's uphill or downhill?
Oh wait, never mind, that says uphill. My bad.
So for it to be strong, the points are very close to the line. The 25th.
Is there 31 days in October?
Yes.
Yeah, Halloween. It's like 5 Mondays till Christmas.
No way.
Do you guys know?
Did you guys know that you shouldn't be talking right now? Okay.
No way.
I know.
All right. A weak positive. So it's weakly going up here. Do you see how it's weakly going up and weakly going down here? So do you see how the points are kind of spread away from the line?
Looks like that's the same slope.
One's going down and one's going up. If you look at this, the points are moving upwards. If you look at this, the points are moving down.
No, I'm talking about strong positive and weak positive.
It has the same slope. That's not the problem. Do you see how close the points are to this one and how far away the points are here?
So how do you determine where the line's going to be?
You put it through the center of the data so that the points are as close to a line as possible. Does that make sense? Okay, so for these two, for it to be weak,
Are we supposed to be drawing these lines?
you don't have to. I'm just trying to explain it to you, though, so you might want to. The points are far away or spread from the line. Since they decided not to put a moderate here, we're going to do a moderate positive here. So a moderate, you'll notice that the points are still close to the line, but they're not as tight to the line as they're like not all right next to each other. Do you guys see that they're a little bit spread away from the line? Do you guys see the difference between the strong and the moderate? Okay. So moderate points are close to the line, but not all right next to the line. So if we're looking at the last one, which is no correlation, do you see how you can't even decide if the points are going upwards or downwards here? Do you see that? So that would be none. They're just like everywhere. We can't even decide where the line goes. So go ahead and get that stuff written down so we can keep getting through notes here.
Calculators never die. No, they never die.
All right. I'm looking, making sure you guys are taking notes and not talking. You should be taking notes right now, Riley. I have a lot more writing up there than you have on your paper. All right. So match the correlation to the graph that best describes it. So we have the same 4 options on all of them. So one of those options is going to be the answer for all of them. So first of all, is this first one going to be positive or negative?
Negative.
Negative. Where's the other negative one?
Bottom right.
The other bottom right. So which one do you think has a stronger correlation? The first one or the last one?
Last one.
That definitely, the points are definitely closer together than these ones. Aren't they more spread away from the line? Do you guys see that? What?
Do you just draw that perfect line?
I have like, you know, like in like paint and stuff, there's a line tool. I have a line tool.
I just thought you had a gift.
Yeah, I'm really good. So which one would this one be? Negative 0.83 or negative 0.91?
Negative.
8-3.
So we said the closer it is to 1, the stronger the correlation. So let me write that down again because that was on the first slide. So closer
Touch to the answer all has
to negative 1, the stronger the negative correlation.
Hold on, you said they all gotta be the same.
What do you mean they all got to be the same?
answer's gotta be the same for all of them.
No, I said there's one for each of them. And then the closer it is to positive 1, the stronger the positive relationship. Okay, what's wrong, Emma?
I just don't understand this.
It's new, so that's completely understandable. And this is only the first example we've really done. Okay, so that's a good question. So Emma just asked, how do you determine the numbers? You guys are not going to have to determine these numbers on your own. Do you understand that? Shh. This is not, that's for an upper level class. That's not for this class. What we're just doing is we're going to give you numbers, and you guys are going to have to decide based on these 4 options which one it matches best. So we looked at these 2, and what I did personally is I said, okay, I see 2 negative answers, so where are my 2 negative graphs? So I looked at these 2 together. The closer it is to negative 1, the closer the points should be together. So which one of those has closer points together?
Okay, I get it.
Do you see that?
It was closer to 1.
1 or negative 1. And 1 is, if it's closer to positive 1, it's a stronger positive correlation. If it's closer to negative 1, it's a strong negative correlation.
Okay, good.
Okay, so that's all I did there. Does that make more sense? What's up?
The one in the top left is negative 0.83.
Top left.
Yeah.
That's the answer?
Yeah, why?
It has to do with the residuals. So it's pretty strong correlation, but it's not as tight to the line as this one here. And we only have 2 options of negatives. So if this is the one that's tighter to the line, that one has to be the one that's closer to negative 1.
Okay.
And like I said, you guys are not going to be calculating this. So all you're going to be doing is you're going to be given stuff, and you just have to select the one that makes the most sense. Does that make sense? If you were to do this, statistics.
Yeah,
You don't, that's not required.
No, but it might end up being a required course in the next couple of years.
Well, I'll be out of high school.
All right. So look at those 2 positive correlations. Tell me which one needs to go with this one here. Grace, which one do you think it is? Do you think it's 0.56 or 0.13? So you're going to have to compare these two together. So which one do you think is 0.56 and which one do you think is 0.13? So be careful. The closer the number is to 1 or -1, the stronger the correlation, which means less spread. Okay? Which one has more spread away from the line? The top one or the bottom one? So this one has more spread, so it should be the smallest possible number. So which one would it be then? So the bottom is 0.13. So if you're looking at this one, this has more spread away from the line. There's really not even a correlation here, right? You can kind of see it going upwards, but it looks like it's kind of just stuck here in the middle, right? So you see how close that is to 0? 0 means no correlation. You can barely tell this is positive, right? So that's why it's so close to 0. But this one, you can tell that it's going upwards, right? But it's not very strong. Do you see how tight these ones are to the line and then how spread apart this is? So it's getting really close to being there being no correlation at all. Okay. Questions there before we do the next one? All right. The next one. Match the correct correlation to the graph. So give me whichever one you want to tell me, but raise your hand and tell me which answer do you think it is. You want to try, Kaylee?
No, wait, which one?
It doesn't matter which one. You choose.
That right corner one.
Okay, the upper right one?
Yeah.
Okay, upper right. What do you think that is?
0.99.
Well, it has to be positive because it's going upwards, right? And it's a really strong correlation, right?
Yeah, like
Aren't
really
those points
strong.
even all on that line?
Yeah.
Do you guys see how? Do you see how close they are to that line? So it's almost 1. So that's why that makes sense, right? Okay, raise your hand and tell me another one you think it is.
Is there ever going to be a time where it is 1?
Probably not. That's kind of a hard thing to have. That's like saying that something is 100% correlated, which that would be really hard to get.
I got one.
1 second, I'm going to call in somebody else. Colin, which one do you want to do?
Alright, I'm going to go for the top left because this is the hardest one.
Why does it sound like Jeopardy?
Alright, so it's going to be the 0.64.
How did you decide that?
It was so hard. I knew that the bottom two were both negative, so there was only one positive answer.
Does that make sense why that would have to be the positive one? And it's definitely not 0.99, because that would say that they're really close to the line. Are these all really close to the line? It makes sense that it's getting closer to that, like, halfway where they're getting spread apart, right? So that's just, in between there. That's a moderate correlation there. Yes, Josh.
The bottom right is
That is definitely stronger correlated than the other one here. So this one here is about a halfway correlation. Questions on determining the multiple choice type stuff there? Any questions there before we look at the next example? Okay, we have some side conversations going on. So let's get started here. Describe the correlation of the data graphed in the scatter plot. You are not going to have to give me the R value. You just have to tell me if it's a strong negative, strong positive, weak negative, weak positive, or moderate positive, moderate negative, or no correlation. So if you were to draw the line of best fit here, Justin Powers, what do you think this one would be?
Strong negative.
It's going downhill. Do you guys see that? Are those points pretty close to the line?
Oh, yeah.
So this is a strong, positive.
I think you need snotty.
Thank you. Strong, negative correlation. Okay, so then we need to talk about the correlation. I'm put curriculum on this. What am I doing?
Is being a teacher hard?
All right. No, you're good. All right. So we talked about how it was as x increases, y does something. So in this case, as x increases, y is as x. Look at it this way. As x goes to the right, what is happening with the y value? Okay, so what is our x value? What is our unit on the x?
Aren't you going to have a point to do that?
No, what is the value? What is the unit on the x-axis? So as the minutes on the treadmill increase, because remember x will always be increasing, so as the minutes on a treadmill increases, what happens? Can somebody tell me what the outcome is? Connor?
The ounces of water in the bottle decreases.
Perfect. The ounces of water in the bottle.
It's not her favorite though. That's
Remember, I wrote who put my favorite is up there because that was definitely my handwriting up there.
I mean, at least you're honest.
I was afraid Mike was about to get up and write on the board. I did not write that up there, Mike.
She wrote that I'm her favorite. She just wrote your initial.
No, that was him that wrote that, and that was you that wrote that. All right, so strong negative correlation. As the minutes on a treadmill increases, the ounces of water decreases. So what is this next one? What do you guys think it is? Do you think it's strong, weak, or strong, weak, or moderate?
It's strong.
But are they really close to the line like the other one?
It's moderate.
I would say it's more moderate. And is it positive or negative?
It's a positive.
Positive, guys.
So it's a moderate positive correlation.
Okay. This one's strong, and this one's weak. It's strong.
Can I have the whole?
The only time, guys, the only time it's going to be strong is like if that line is going through almost every single point. Does that make sense?
Yeah.
Listen to me. The only time it's going to be strong is if that line is going through and hitting almost every single one of the points. Do you see how that line basically touches every single one of those points?
Oh, yeah.
Whereas the other one, there's points off the line. That's what makes it strong. So what is our statement as what? So what's my statement, Lexi?
As the minutes on the treadmill increase, the more calories burned.
So you're also going to say that as increasing. So the calories burned.
Increase.
Yes. So as the minutes on a treadmill increases, the number of calories burned increases. Still no.
I don't know. I was asking. Who here has seen the Magic School Bus Rides again?
I saw one episode.
Guys, this is not the time to talk about that. All right, when you're ready, flip to the next page. If you have questions, let me know. Yeah.
Are we gonna finish this before we go to lunch, or are we gonna?
I don't think so. I think we'll have to work on it. No, wait until lunch. I really need to get this done. We might finish it. I'm not 100% sure. So, guys, focus.
You're distracting me. Other me.
Guys, I'm going to wait. Please stop talking. All right. So we're going to talk about causation now. A causation is a relationship in which one action or event is the direct consequence of another. Correlation does not imply causation. So you're looking to see if the fact that these two things are correlated, so even though there's a strong correlation, could that imply causation? Does that make sense?
Yeah.
Causation is a relationship. So let's look at this. So can you think of another reason that might have caused a need for both more firefighters and an increased damage? So if you notice here, as the number of firefighters increases, let's write this down first. So as the number of firefighters increases, the damage in dollars also increases. So this does not mean, so we're asking, does this correlation imply causation? Do the number of firefighters directly cause the damage?
No.
No, so would that imply causation? No. What could be the reason why? What could be the reason why having more firefighters could cause more damage? What could be happening here?
Wait.
Bigger.
Why would that make sense? If the fire's bigger, what would you might need?
More people.
More people. So the fire might be so big, which is the reason the damage is being caused, that they need more people there. So the fire I'm sorry, the bigger the fire, the more firefighters you need.
I have a good one.
Oh my gosh, I'm really worried about this. Go ahead, Connor.
Okay. So the number of firefighters. Okay, this is a stretch.
I know, I'm
But the
pretty
number
sure
of
I was aware of
firefighters
this.
Could be the number of people that. Okay, well, we need some backstory first of all. So
Phyllis.
hold on.
I'm waiting.
Okay, so number of firefighters could be the number of people your wife is dating. So.
Okay, we're done.
Okay.
It took a really big turn really quickly.
No, just because the number of firefighters means that there's more damage in there, would it make sense to send less firefighters if there's a bigger fire?
Yes.
Yeah, totally.
No, it doesn't. So this does not imply causation. So what are your questions about what is causation? Please ask questions about what is causation at this point. I don't.
I do.
Went from a 2 to a 10 really fast.
It did. It was fine at first, and then he did a backstory, and then it was like, nope.
The property damage goes up the more firefighters.
All right.
That makes
So what kind of correlation is happening here? Is it strong, weak, moderate? What are you guys thinking? Strong, weak, moderate?
Moderate.
Moderately?
Negative.
Are they? Oh, is every point touching this line?
No.
Listen to me. Stop talking. Is every point touching this line? No. So this is moderately negative. So what is this saying? If you were to write this as, you would say as what? As what increases? Yeah.
As the shoe sizes increases, the grade in algebra 1 decreases.
What?
As the shoe sizes
Okay, granted, if you have bigger feet, does that mean you do worse?
Yeah.
What?
I'm a size 7.
No, not right now. I'm in the middle of notes.
Guys.
So, guys, would this be causation? Does your shoe size have anything to do with your grade in Algebra 1?
Yeah.
Sure.
No, it does not. Shoe size does not change, does not affect the grade in Algebra 1, but there may be other factors that would predict your grade in Algebra 1. So, no. Shoe size, I cannot do notes if you guys keep talking over me. Do you understand that? I have to, yell over you. I shouldn't have to yell over you every day. So, shoe size is not a predictor of grade. So what kind of correlation is this one? What kind of correlation is this one? Yes.
Weak positive.
You think that's weak?
Oh no, it looks different on my
Well, it could be weak.
moderate.
I could see weak too. I could see moderate as well.
On my paper, they got this going isolated.
Well, there is that random point off there. It depends on how I drew this line. Because if I would have drawn this line here, right?
That's moderate. Still random.
There's that random point down here which makes it weaker, right? So I can see that. So this is a weak positive. I would probably also accept moderate positive at this point because they're not like super spread away from it, but weak positive because that point is off to the side there. So what is this saying though? As what? Riley?
As the average daily temperature increases, the visitors will increase as well.
Where is it increasing at?
The beach, place
I'm going to call it the number of beachgoers increases. Yeah. Pretty sure it is.
Google it.
I got the answer.
So, is this causation? Is this causation?
Yeah.
What do you think, Justin?
Yes.
So, I can see why you guys think it's causation because it makes sense, right?
Yeah.
Technically, just so you guys are aware, technically you cannot assume causation ever. So instead of saying yes, we could say maybe, right? I mean, I would say there's definitely no situations like the shoe size and the egg grade, right? But you can technically never, like, say that something is caused by the other thing. But this is a better chance of it being correlated and caused by the one thing than the shoe size and algebra grade, right?
So your answer to would this be a causation will never be yes.
Correct. In this case, I would say maybe, because certain times of the year have higher temperatures, which causes people to go to the beach, right? And so the reason for that is, let me finish writing this or else I'm going to write what I'm saying. So the reason for that is that, like, obviously in the summer, the temperatures are higher, right? So people tend to go to the beach more. But say it spiked to 90 degrees in the middle of winter. Do you think people would end up at the beach probably?
Yeah.
For one day?
Yeah.
Probably. It's not.
You know there's those
you don't get that often in the winter.
But I mean, you're gonna have to search through all your clothes and find your beach clothes. You know what I'm saying?
You know, there's
I
those
just write it all the
keep
time.
my
Yeah, I keep my.
I keep mine.
Right, I can see that, yeah.
It's worth it.
You know,
I
see?
do it.
All my
It's
winter
worth it.
clothes are
It's
regular.
worth it.
All my winter clothes are regular clothes, so.
Yeah, true. You are always wearing.
That is your Beyonce.
All right.
All my clothes are black.
All right. The last things we have going on here is predicting the residuals in 11 minutes. Oh, shoot. So a line of best fit. A line of best fit is the line that best models the data. We've kind of been talking about line of best fit this whole entire time, right? I've been drawing it in for you each time. Your line should go through or around most of the points and have an equal number of points above and below the line. So you want it to go through the center of it, but when I say equal, so this is what always confuses kids. So I wish I had, one second. Okay, so this is what I get sometimes. So don't draw this. This is on the previous example. Sometimes kids will literally slice their line like this. Because they're like, well, Mrs. Brady, I have 4, and I should have cut through. But they'll be like, I have 5 on the bottom and 5 on the top, so it's equal. That's not what I mean by that. Do you guys understand that? And I get why kids say that. Do you understand what I mean? I get why kids say that. So it's not just the fact that they're equal on both sides, but those points are also as tight to the line as possible. When I drew that pink line in, were they very tight to that line? No, it doesn't even follow the relationship that's happening there. So you have to be very, very careful when you draw the line that when I say that the same amount of points on the top and bottom, what I mean by that is it's going positively or negatively if that's what it's doing, and it's going through the center we want to minimize that residual value. A graphing calculator computer will compute this equation for you guys today in today's lessons. On Friday and Tuesday, we'll be doing it by yourself. A residual is the actual value from the data, so the point plotted on the graph, minus the value from the equation. So this is the point on the line. Since the order matters in subtraction, make sure you always subtract your true value, which was a given value, the original point, minus the value you expect, which is based on your line. The residual can be positive, negative, or 0. If it's below the line, it's negative. If it's above the line, it should be positive.
You know, you don't have a block day the whole month of November.
You do in November because the week that you guys have a 4-day week and you guys have that Friday off, we have a PD day that day, so they're still doing a block day that day.
Oh, no.
It has nothing to do with you. It's stuff we have to do.
Thursday.
All right.
Yeah, is it a Thursday?
It's a D day that week.
don't know what that is.
So
That's the really short Thursdays.
That's when we get off with the
That's when
other
we get off
sports
usually when
people
we
at
go.
school. It's like middle school and
Yeah.
Wait, what?
All right, the data below shows the number of vehicles Y that were cleaned at the car wash X hours since the car wash was opened. Given the graph and the equation of the line, find this. So this is the equation of the line. Y equals 1.069x plus 0.52. So this point is actually like 1, 2. This is 3, 4, 4, 4. So do you see these square points are the points that are up here in the table? Everybody see that?
Yes.
So it says find the value if the car wash has been open 9 hours using your equation. So our equation is Y equals 1.069x plus 0.52, right? Where would we plug that 9 in for? So we plug in 9 for x. Okay, go ahead and plug that into your calculator. Do 1.069 times 9 plus 0.52.
Wait, what's the value? Wait, is the value the number of words?
Yes.
Okay.
Zero.
I know.
Cassie, what did you get? So we get Y equals 10.141.
That's not what I know. 6, 9 times.
Oh, you never added 0.52.
Oh.
Did anybody else not get that so I can help you?
Now I got it.
Okay. So when you calculate the residual, you calculate the actual minus the equation. So we know that the equation is 10.141. What is the value at 9 for the actual? What is the value at 9 for the actual? Yeah, it's this point here, which is 9, 11. Yep, you'll see that there on the graph. So we do 11 minus that. Jayla, tell me what you get. What'd you get? 0.859. So your residual is 0.859. Is that a strong, moderate, or weak correlation there? That's pretty strong, right? We said if it's bigger than 0.7, it's pretty strong, right? So that point is on a strong one. So this is probably a strong correlation here. Do you see how close all these points are to the line? This one is a strong correlation here. So that's how you know you have a strong correlation, is you find the residuals. Now, we going to make you do that for every point? No. You can look at it and see that. Does that make sense? Okay, let's look at the next one. It's still the same one. Guys, the amount of talking needs to stop. We're on the back page, right?
Yes.
Okay, so it says find the value of the car wash after it has been open for 4 hours. So where do we plug that 4 into in our equation?
X.
Okay, go ahead and plug that in for x and get your y value out. Justin, pick your head up.
Maybe we'll see some stuff tonight. That's a video. He opens the.
Emma, when you're done, tell me what you get.
4.796.
Okay, because after 4 hours. So we always do the actual minus the equation. So our equation value is 4.796. What is the actual value for 4 hours? says 4 in the graph, and if you look here, it says 4. So you do 4 minus that.
Oh, shoot. Whoa.
Brian, what do you get?
Negative
Yep. So this is below the line. Still pretty close to the line, though, because it's 0.796, so that is a strong correlation there.
Ah, that makes more sense.
Well, this is a strong positive in general. This just has to do with the residual. How close it is to 1. So, guys, let's talk about that because we have to be careful. The correlation is different than the residual. Do you understand that? You can use the residuals to figure out how strong or weak something is, but the residual number does not tell you if it's positive or negative. The fact that this is going uphill tells you that it's positive. Do you guys see that? So the residuals being closer just makes it you realize that the correlation is stronger. Okay? That's what that tells you. We only have one more?
Yeah.
And then I'm going to get you guys your homework when you get back, and we're going to do a problem together. So for 7 hours, go ahead and plug 7 in for x. We leave in like a minute and a half. Alyssa, what did you get? Okay, so we always do the actual minus the equation. So my equation value is 8.003. What is my actual if it's 7?
Actual is 8.
So your answer is 7.
So if we get that, we get negative 0.3. So that's basically
0.
Yeah, it's basically a 0 there.
Which is
That means that it's. So I guess so. The residual being right on top is that's good.
I thought you wanted it to be close to.
All right.